Hello there, and today is our final session, week 13. Focus of today's discussion is your final examination. It's a structure and some of the key areas and important areas that you should be focusing on to be better prepared for your finals. So, some of the key points that I'm going to discuss right in the next section, starting in a minute. So some of the important topics, let's quickly recap. So value added waste analysis is an important area that you should review your notes and the tutorials and of course your assignment one. So in terms of value added analysis, we decompose process into a step and then we look at these steps and then we ensure that we do have the atomic level of decomposition, and we look at the step before the task and we look at the step post task to see whether the output of a task is ready for the next task. And then of course you clarify each step into either value adding, business value adding, or non-value adding activities. Right now you know the definitions of value adding, non-value adding, and business value adding activities, right? So you read this example. So we have different what we call examples in your tutorial. Have a look at that. So for example, value adding activities are necessary or useful for the business and for the customers, specifically for the customers, and our objective is always to maximize these value adding activities. And the criteria for these activities are whether the customer is willing to pay for this step, whether the customer feel that this step is absolutely necessary to achieve the customer's goal, right? If, for example, we eliminate this step, will the customer perceive as a negative impact on the quality of service or the product? Is this step important for a product for the finalization of the product? The changes the form of the product, right? Or for example, meet a quality criteria, right? And I give an example of ice cream, if you recall, and you can always watch the tutorial there. And as I said, a customer willing to pay for this activity. So for example, in terms of a order to cash type of process, confirmation of delivery date, delivery of the product, in terms of university admission process, which we use in this unit, is the assessment of application, right, and notification of admission outcomes, etc., where we are engaging directly with the customers in order to provide information to the customer to achieve the customer's goal. Okay, the next will be business value adding activities. So our focus is to depending on the nature of business value, our focus is to either minimize or if it is important one from a business perspective, in some cases we can maximize as well. So activities like which fits into this particular type of criteria, particular type, are necessary or useful for the business to operate. So these are rules, regulation, policies, laws, many other elements. So the criteria you may need to analyze is the step required in order to collect the organizational revenue, improve or grow the business, for example, meeting some corporate guidelines or framework or quality requirements. Would the business suffer in long term if the step is removed? So for example, in your process analysis, or you're looking at an activity which you feel that can be eliminated because the check or the decision point is unnecessary, but maybe this point or this decision is very important because it might hit us in long run, right? And we may get affected because of a specific legal requirement or company's bylaws or something, right? So these are for risk mitigation activities. You need to be careful. Does it reduce the business risks, right? And is this a step required to comply for any regulatory requirements? So a couple of questions you have to analyze, you have to ask to assess that particular activity. So examples in terms of order to cash process are the check purchase order, check customers credit worthiness, because the objective is that if we are supplying our products to a customer on credit and the customer may have a bad credit history or have no means to pay the invoice, then I think it's going to be a bad debt or a loss in future. And for example, university admission process, we have verification of completeness of applications, or I'm checking the validity of degree, because let's say somebody just put a fraudulent or a fake document and you accept that student into your programs, and later on the student was not able to perform because he never actually attended the prerequisite knowledge. And yeah, it's a loss for the student, it's a loss for the universities as well. Okay, all right, so this is business valuating activities, and then next one is of course non-valuing activities. So our idea here is to remove from a process because these activities are non-value, and these activities are anything which is not a value adding activities or not a business value adding activity, and of course a customer is unwilling to pay for or use that particular service or product. Is just gold plating. It does not contribute to the product and its feature itself and the value of the product. Does not improve the form, the quality, or a function of a product or service, right, to pass through an acceptance criteria. The activities customer is not going to pay, and it's just unnecessary consumption of time, effort, and resources. So these particular type of activities include handovers, context switches to changing document from place to place, waiting time, delays, right, rework, and defect correction, not the inspections. Okay, so for example, forwarding purchase order to warehouse is a non-value activity because there's nothing happening on the purchase order. It's just a waste, which will open up our next related topic, which is type of wastes. So we know that we have 7 plus 1 types of waste, and you will be in this exam you will be only tested on the 7 types of waste, but just let's look at the slides here. So we have conveyance, transportation, motion, where the resource is moving from place to place, or cell to cell, or machine to machine. So conveyance is that product is moving, or transportation is a product is moving, or the object we are working on is moving. Motion is that resource is. Then we have the inventory, and then we have, for example, waiting. These are the 2 other waste type under the category of hold waste. And then we have overdoing types of waste, which is overproduction, overprocessing, and corrections. And let's move on and quickly look at each one of them. So the waste analysis, first one is our transportation and conveyance, which is the unnecessary movement of the material and goods. Is a waste. Transportation is waste, is the movement of material. Okay. So example, step in the process could be distance travel, or moving documents from one place to another place, sending files, etc., etc., etc. Right? Okay. So the next one is the motion, which is unnecessary movement of people and equipment that is actually working on our final product or the service in a process. So it is again the waste of motion. Examines how um, people move to ensure that the value is added. So for example, in a restaurant's case, the cooking staff will have to move from different types of equipment, or what we call it a cell, to a different so for example, if I have a cell which has all my chopping machines, then I need to, let's say, chop my veggies, and I'll go that's about 100 meters distance between the chopping station versus, for example, the frying station. So it's the motion. All right, so actually it's both, because your product is also, or your transportation waste is also there in this example, and the motion example is also there. Okay, right. So next we'll be looking at the inventories, right? So inventory is the liability of material that are bought, invested, and not immediately sold or used. So they're just lying there in our warehouses. We over purchase, or sometimes we under purchase as well. So one is called a stock out situation, other one is called overstock situation, right? Okay, so the waste is, if you remember, we mentioned that the inventories can cost us money. For example, keeping inventory requires certain expenses, which we call them the holding expenses. For example, fumigation, palleting, and of course the labor cost to actually move inventory from different pallets to another. So for example, transactions are not processed in case of a service sector. Inbox then outbox is, inbox is more, meaning we have a queue here. We have got too many cases to handle. Over ordering material consumed in-house, so we have got too much of material ready and not enough sales, and over ordering the raw material or whatsoever. Okay, right. The next one, of course, is the waiting. So waiting is a non-productive time due to the lack of material, people, and equipment. So basically, you know that now you should be able to bring your knowledge of queuing analysis and say, okay, so waiting is actually related to queues, because if I have process A and B, and process A has got an inventory problem, it means there's a long queue waiting to be processed. They will only generate the amount of output as much as their capacity. And if that is the case, you notice the process B will have less inputs than its capacity, and that will be the waste of resources. So processing done once a month. So let's look at an example here and look at the slides and on this particular week tutorial as well. All right, so next will be our overproduction analysis. So overproduction is a waste when we produce more than the next step needs, or more than the consumer purchasing capacity. All right, so we are just holding stocks. So waste of overproduction will relate to excessive accumulation of work in progress, which is goods which are still in process, not partially completed, as well as what you call the finished good inventory, which are ready to sell the goods, but we don't have either the buyers or the customers, or there is no demand for a particular product or service. Next one is your over processing, right? So over processing is when task, activities, and materials are performed without any value addition. So waste of over processing will always relate to anything which is not doing any value adding to either the product or from the internal customer's perspective, right? So for example, and I give you an example of our leave management processes and our traveling processes, etc., right? Okay, right. So correction or redo in the terminology. So redo is basically we perform our work, and now there is a defect in our final product, so we need to fix those errors, and that will be considered as redo or correction error. So the waste of correction includes the waste of handling fixing mistakes. So any loops in a process where errors correction is there is considered to be a waste of redoing or waste of correction. Okay. All right. So for example, if we enter incorrect data, our process will perform what it's supposed to perform, and the output will be incorrect, and then we have to request the customer to re-enter the data. Now, an interesting example here is about your assignment 2 submissions. I think we clearly mentioned that attach your final simulation file with your submission file back. But very few of the groups did attach their simulation file from BIMS. And now we are requesting from all groups to send their last version on that particular date, so that we can run your simulation and see whether your simulation is correctly performed or not. So that's a waste, because we are spending time, we are waiting, because we can't unmark your assignment 2 unless we have that particular file in our hand. Okay. So when you look at your tutorial in week 3, when we have done the waste analysis, look at the example here right there, and for example here we are looking at the airline company, right, uses the central telephone bank and semi-automated telephone process to take reservation, and we have this scenario. All right. So I think sorry, I mean that's nothing to do with the waste. All right, so so that was about the value adding and waste analysis. Please make sure that you visit that particular stationary request problem and have a look at the tutorial for that particular week as well. Another important topic was the quantitative technique we use, called the Pareto analysis. So let's look at this exercise and scenario here. So we have this airline company scenario, and we receive some data, which is complaint data, right? And from that, we like to understand how to actually analyze and say what are the 80% vital problems, and we should be focusing on to address compared to compared to the remaining part. So the logic is that what are the 20% vital problems, right? Okay, I think I'm still not awake. Let me rephrase. My apologies. So the Pareto analysis will be identification of 20% vital problems that causes 80%, all right, of the issues in organizations, right? So your Pareto analysis, step number 1, arrange your data from highest to lowest order. So for example, we arrange this data from highest to lowest, right? So from so we put into descending order. And then step 2 will be, right, calculate the percentage for each element by dividing, right, our each factor. So for example, what's happening here, we divide the excuse me, let me show you what's happening here. So what's happening here is we are dividing each of these value. So for example, 420 divided by the total number of cases, which is 744, and then we say that that is 56%. And then we did the same treatment for the next one, right? And then we of course add what you call calculating your cumulative percentages. So basically 56 plus 25 will give us 81%. 81 plus 11 will give 93%, and then 93% plus 5% will give us 98%, and 98 plus 1% will give us 99%, right? And 99% plus 1% will give us 100%. So remember that this is basically 8 divided by 744, and 10 divided by 744, 37 divided by 744, 85 divided by 744, and 184 divided by 784, right? And then you go to step 4, which is basically construct your frequency histogram, right? Using any tools you are familiar with, okay? Like that. All right. So I'm going to take another more important example for you. So in your final exam, you will be given let it open. Is a big file. You're not going to get that big file for in your final exam, but you will expect a file. So you will receive in your final exam all the data files in required formats. Okay, so now this is our data. So this data is from a government department, and you can see that we have the date received, and we have got the credit card, or the type of, or the area where the complaints was received, and then the nature of issues. Okay, so you're gonna get a data file like this if this question is requested in your examination. Okay, so I'm going to show you something very quick and very easy, and don't get overwhelmed. So you notice that this is a huge data file which has almost about 903,000 cases. Okay, so how do we perform our Pareto analysis with such a large set of data? The answer is it's very, very simple. All right, because you will have access to your tools in your examination. So what I'm going to do here is I'm going to select my data. So click on your data file in your first column, and then you can use what we call Control plus Shift key together. So for example, if I say Control small change, let's say Control and plus A key, right? So you say go there where your data is there. Control A is going to select all cases in your data file. Of course, if you are not happy with that, you can always do what I'm doing right now, which is basically using your mouse and drag and drag, right, until your data is there. All right, so let me try my technique. So I'm going to use Control A key. So it has selected every line of data in my Excel file. I'm done. Then I click on my Excel insert option, and then you will have something called recommended pivot tables. We click on the recommended pivot tables, and that will show you what kind of table you need. So we are looking for not the count of product, we're looking at the issues. So we like to understand the nature of issues. So click on the relevant pivot table. So in this case, because we are looking for column C is about issues, and of course you just double click on that option, because it's a very large file, you will see a pivot table with such data. So you notice that it summarizes all your data files into something which is more manageable, right? And nicely done. Now we can easily do, we can change the label. So instead of count of issues, we can just look at as the type of issues, right? And we say, sorry, type of issue is this one, type of issues, and then we have what we call the count of issue, right? And then we select our data again here, because remember step 1 says that we must need right, in descending order. So we select our data and then we copy this data, create a new sheet, and then we simply pasted this data. Now that's our data, which is all together. And next what we're going to do is we're going to select our data, okay, just like that, and we're going to sort our data by clicking on sorting. So data sorting, custom sort, and then we can select by count of issue, the second column or column C, and change it from largest to smallest. That's for the step. So now you notice that we have all data nicely, right, aligned. Next is pretty simple. Select your ready to use data, click on insert, click on recommended charts, and then you will see your Pareto diagram ready for you. And then you can enlarge it, and there you go. Okay, so for a large data set where you've got hundreds and thousands of records, a tool like Pareto will be extremely right, good, and tools like Excel will be extremely good. All right, so that's your Pareto. The next is, of course, you need to explain what is happening here. What are these few problems which are causing 80% of the issues, right, in your system. All right, so let me repeat. So this time I'm not going to use all the data here. Let's say I'm only selecting anything which is above 10,000 problems, and then I click on insert, recommended chart, and then click on my Pareto diagram, and now you can see that that's a bit more easy to understand for us. And there you go. So now if I ask you what are the 80% problems, we know that 80% problems, we can see and draw the line that 80% problems will be up to these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? The point where you reach that 80% access level are, right, so I can draw it for you just to make life easy for you to understand what I'm doing. Excel doesn't allow me to, oh, it does allow me to draw. So you can see that we're talking about, okay, let's change the color to something different. Let's say green. So here, that's the axis we are touching, and then it is hitting that point. So all these activities up to this point, or all these problems up to this point, from here to here, are the most important problems that we need to address. Okay. Yeah, so make sure that you have a clear idea on how to interpret your findings as well. Okay, so Pareto analysis, step 1, arrange data for large sets. I explained it to you to use Excel, and you are it's perfectly fine to use Excel for your final exam if you're getting that question in. All right. So using Excel, you don't need to do your step 2, and you simply don't need step 3, right? And then you can straightforward go ahead with step 4. So using Excel will actually cut your time down to quite fast, so you can only perform step 1 and step 4 if you're using Excel. If you're doing manually, then of course you need to follow this particular process and draw your diagram as is. Okay, the next key area was about Six Sigma. So in Six Sigma, apart from, of course you know that because it is an open book, open notes exam, we're not going to ask you anything which is from your memories, or you can actually look at your notes and copy and paste. So questions are very analytical. So Six Sigma, there are 2 measurements we discuss in our lectures and tutorials, which cause the defect per units and of course the sigma level. So defect per units are calculated as number of defects divided by number of output or units produced. Or in other words, it can also be calculated as the defects times the number of units and the sum of it, which is weighted average formula, divided by the total number of units produced. So DPU, or defects per unit, quantifies the individual defects on a unit and not defective units. A defect accounts for 1 error on a unit. Defect units refers to a unit that has at least 1 defect, and there can be units which can have multiple defects as well, right? So the question is a process that produces 1 DPU better or worse than the process that produces 4 defects per unit? The answer, of course, is looking at the Six Sigma level, right? So the next measurement after you calculate your DPU is the DPMO, or defects per million opportunities, right? How do we calculate the defects per million opportunities? Is number of defects divided by number of outputs times the opportunities per units into 1 million, because we're talking about Six Sigma, right? Per million opportunities. Or in other words, you can simply calculate as the DPU divided by opportunities per unit times the 1 million criteria constant. So let's look at an exercise here. So a matrix chart as depicted in this table indicates that the output or the outcomes of the 100 meals in a restaurant, right? So we assume that there are 6 possibilities or opportunities for a defect per meal, right? So we know that there are 6 possibilities the data tells us are possible, and then we have defects and meals. So 70 meals were without any defect, so that's good. 20 meals had 1 defect, 5 meals had 2 defects, 4 meals actually contained 3 defects, and no meal had 4 defects, and 1 meal had actually 5 defects. So defect could be the food was not warm, the seasoning was too much, all right, food was not well prepared or well made. So for example, if you're ordering a steak and you order for medium rare and somebody provided you rare, right? So many defects, right? So there are 5 errors in that particular product. So how do we determine our DPU, and how we determine our DPMO, and what is our Six Sigma level? So we know our formula that defects times unit divided by number of defects. Now I'm going to use that formula for this particular exercise, right? So 0 times 70 will give us 0, 20 times 1 defect, 5 times 2 defect, 4 times 3 defects, 4 times 0 defect, and 5 times 1 defect, plus the total number of meals. So it is 70 plus 20 plus 5 plus 4 plus 1, which is 100. And once you solve that, you're going to get 47 divided by 100, which is 0.47, of course, right? And then we're going to look at our Six Sigma level. So Six Sigma will be calculated in this case, the second formula, right? The second formula was we take our DPU or DPU divided by opportunities times 1 million, and once we solve that problem, we're going to get an answer as 78,333 per million. Now to understand what is this 73,000, how we can actually translate this 73,000 into a sigma level, right? We need what we call the Six Sigma or sigma table. So you will have access to this table. Is one of your tutorial. You will need these tables in your final exam. So where exactly we have our 73,000 or a closest value? So we look at, obviously not in the first column, what in the, so it's not here. Then we look at the second column. Is there anything? So we have 6,000, 28,000, 66,000, 80,000. So obviously 78,000 is very much close to 80,800. So we will say that Six Sigma level is 2.9. All right. And yeah, that's about it. Okay. So once you have Six Sigma level, then you will interpret what this Six Sigma level. So it means that this particular process of a restaurant is at 2.9 sigma level, and there is a probability or possibility of 80,000 defects per million meals we're going to produce. Now, if we know the average cost of a meal, let's say average cost of a meal is $30, then 80,800 multiplied by $30 will be the cost of these defects. Okay, right. Of course, an important area was your flow rate analysis, right? So flow rate analysis, you will be tested in your analytical capabilities of looking at the cycle time. So we are looking at, we will be looking at some sort of a process model, right, which will have various features like loops and XOR gateways and blah, 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 right? So we will be asking you what is average cycle time. Again, it is assignment 2 and assignment 1 all together, right? And let's do a quick exercise here. Okay, so we have this diagram here which has got, we receive a case and then it goes through check completeness, and check completeness can result into some cases rejected and reverted back to the applicant. So in this case, 20% cases will be incomplete and sent back for additional information. 80% will follow through. All right, so we address that one, right? So the formula, because there is a loop here, right, we're going to use a formula which you already have as T divided by 1 minus R. So in this case, let's recap. So we know that 80%, so will pass through this pathway, right? So that's no and that's yes, right? So 80% will pass through. So that's our R. R is repeat loop, right? So which is 20%. So 1 minus 20% is 80% or 0.8, whichever you like. So 1 divided by 0.8 is basically this average cycle time, considering all possibilities here, is 1.25 days. Next we have another gateway. So that was our XOR gateway. Now we have a parallel gateway or AND gateway. So we know we're going to apply the max rule, right? So if we are looking at day 1 and day 2, so we are looking at max, right? Which activity? So we have 1 and 3. So the cycle time here is 3 days, right? Plain straightforward. Then this is in a sequence, so straight ahead, 3 days, nothing to worry about, right? And then again we have an XOR gateway, but this time is a bit of a different, it's not a loop, it's basically looking at the probability. So 40% will take notify rejection and 60% will be making credit, or will make the credit offer, and then the process will end. So we're going to look at this particular right box now. So you notice that I'm dissecting my process into smaller chunks, so that makes my life easy. So the idea is, or logic always is, that if you have a very complex process, always try to convert that process into a sequence, right? Process 1, 2, 3, 4, 5. That makes life very easy, because that's what you do in flow rate. So the next one, we're going to use our XOR formula, which is the activity times multiplied by the probability of that particular pathway, right? So in this case we have 60% will take 1 day and 40% will take 2 days. So 60% into 1 and 40% into 2, the average activity of this particular segment of the process will be 1.4 days. And finally we add all of these together, right? So when you add together, we're going to have 1.25 from first section of the process, 3 days came from the second section of the process, 3 days came from the third section, and 1.4 days comes from the final. And then altogether we are saying that from here to here, our average activities or average process cycle time will be 8.65 days. Okay, right, so practice all these formulas. You need them. Okay, so I'm going to jump on to the 2 other remaining part, which is the queuing analysis. In your final exam you will be tested on queuing, both MMC and MMQ. So let me get rid of the slides first. And I'm going to not this one. Okay, so this document is also available on your Blackboard. Okay, so first one is to understand what is our arrival rate. So we use a formula to calculate our Poisson distribution for any kind of problems like that, right? So the formula is basically a probability of end customer arriving, right, will be lambda times time or n divided by n factorials. So it looks very aggressively complex. Formula is quite simple. Probability for Pn is the probability of n arrival in t time period. Lambda is the average number of customers arriving per period, which we will provide you and will give you in the exams, right? And Euler's E is basically a constant value of 2.7183. Let's take an example. So management of a large departmental store is redesigning its customer service process, and they believe that accommodating 4 customers is very important, right, per hour. So customers usually arrive in their experience at the rate of 2 customers per hour. And the question we ask is, what is the probability that 4 customers will arrive at any given hour, right? So that is our question management is asking. So like always, as I mentioned before, you have to use your data very carefully, right? So we required n customers. Okay, can I change my display here? Okay, I'm trying to change my display so I can write, but that doesn't look like. Okay, so let's look at. Okay, so we have n, which is equals to 4, right? Then time, we said, okay, so time is 1 hour, and then we are given that 2 customers per hour. So step 1, right, plug in the value. So we know the formula is basically lambda times t. So arrival rate lambda is 2 times t is 1 hour, so we multiply it by 1 hour. And then n is 4 divided by 4 factorial, right? How do you calculate 4 factorial? Is very simple, right? Is 4 times 3 times 2 times 1. 3 factorial will be 3 times 2 times 1. 5 factorial will be 5 times 4 times blah, right? And of course, then you first divide. So 16 divided 24 is 0.667. And then you have taken your calculator. Okay. There you go. So you may need a little bit of a scientific calculator. Okay. So when we solve e times x, is basically we are looking at -2 times 1 and then e power 1, right? So that will give me the value of 2.7.18, right? Okay, I'm finding it a bit funny, this calculator. All right. So e power x times -2 times 1. Okay, this calculator is funny. So nope. Okay, guys, I'm kind of finding this calculator funny, but I can use my normal calculator. It should work. So -2 times x. Yes, that's what we got. Okay, let's figure that out. So how did we do that? We said the value. So -2 times 1 is, of course, what the hell is happening here? -2 times 1 will give us -2, and then we click on e power x on our calculator, and that will give us 0.135, which is this value here. All right, and then simply you multiply the two values together in your formula, you get 0.09 or 9%, right? And then you interpret, right? So interpret in terms of what's happening there. Okay, then the next important calculation was the service time or exponential distribution. So formula will be probability of service time will be equal to 1 minus e power negative mu, right, times t, whereas the negative mu is average number of customers completing a service per period. T is the service time for the customers, and big T is the target service time. Okay, so let's look at an example here. So the management of the same department, right, must determine whether more training is needed for the customer service staff, and the clerk at the customer services desk right now serves an average of 3 customers per hour, and question is, what is the probability that customer will require 10 minutes or less per service? So let's look at our solution, right? So again, we extracted the data. So the average time is 3 customers per hour, and we are looking at whether there will be a probability that service time will require 10 minutes or less time. So first of all, always convert your data, because sometimes now here we have an hour and time and minutes problem, right? So ensure that your data is in the same units. So because our mu is 3 customers per hour, we will first convert this into minutes or hours, right? So for example, 10 minutes, right, will be 10 divided by 60, so it's 0.16 hours, right? And then we can continue our analysis here. Okay. All right. So then you plug in the value in the formula again. So 1 minus e power negative 3 times 0.67, which is the targeted time period. And once you answer this one, you're going to get 0.666. So 1 minus 0.606 will give us 39.4%. So we will interpret that there's a 39.4% probability that customers will take less than 10 minutes, right? So it's not very high. So therefore, there's no need to do anything, right? Okay. So there is another question for you to practice more, right? So I will look at the other exercises as well, okay, because that will help you to practice your probability distributions. Okay, so the last important area is your queuing example. Okay, so again I'm going to use your our PowerPoint, right, to walk through. So that's lecture 6, right? So queuing examples and queuing theory we discuss in detail, and also you have been experimenting in your assignment too, right? So the queue depends on the service, which is our process, right? So that's something where we are doing our work. It's the point where we get the inputs, and because of the cycle time and utilization problems here, we create this waiting line, right, which is actually also a function of the arrival rate coming into this waiting line, right, etc., etc. So so lambda is our arrival rate, Mu is the service rate or performance of the cycle time, right, by one server, and C is the number of servers or number of desks or number of um, kiosks, number of staff supporting. So yeah, so let's look at our updated model here. Okay, so given an arrival rate lambda and our service time mu and availability of resources or servers as C, we can calculate occupation rate, which is also called the utilization rate. If you are not very happy with the term utilization, occupation is also called, in actually we use the term utilization. Okay, so we use utilization, all right, and then we can calculate our WQ, which is average time in a queue, W, which is the average time in a system. So that's WQ, this is WQ, and of course LQ, and that is the whole thing when the customer got out of our system completely. So LQ is the average time in the queue, how long I have to wait. For example, I might have to wait for two hours to get my job done, which is only takes 5 minutes, right? So that's the 2 hours LQ, and the total time, which is 2 hours and 5 minutes, will be my average time in a system, right? That's what the 4 areas we calculate, 5 areas we calculate: the row, the WQ, the W, the LQ, and L. Okay, so there are a few relationships we have to remember as well, that the total time in a system can be calculated as the arrival rate times the waiting times, and time in a queue can be calculated arrival time times the waiting time in a queue, and waiting time in a system can be calculated also as its waiting time in a queue divided by 1 over mu, right? So we can drive every one of them if we know either one of the parameters. Okay, so some assumptions we normally put in our queuing analysis. For example, we must ensure that time between arrival and service time follows an exponential distribution, and we're gonna use one server, right, model, and it's first in first out method, right? So we're gonna start using our first formula, which is rho, or this is not a P, if you remember, it's called rho. Can be calculated as capacity demand divided by capacity available, which is lambda, arrival rate divided by our average, right, cycle time, right, of that particular activity. Okay, so let's quickly do a example together. You have seen this example, so I'm not going to spend much time. You can read this example, but everything is clearly defined. We're doing it second time. Okay, so let's look at, so if we look at here, in this case is 2 projects simultaneously we're going to run, which is the second part, right? Let's do it one by one. So first one is single server queue with single person. So we have arrival rate as 1 customer per month. So 1 customer per month. We are assuming that working month is 20 days, right? Not 30 days. So this company is, you can have 24 days, you can have 26 days, and obviously you can not have 30 days altogether, because there will be at least one day of break. So 1 customer divided by 20 working days, and then we have 1 customer divided by 15 working days, because that's the average time is taken, right? And if you like, you can use the decimal, which is much more easier to address. So first we calculate our utilization, which is 1 over 20, right, divided by 1 over 15, and which will give us a utilization of 3/4 or 0.75%. So we'll say that because rho is 0.75 or 75%, which is less than 1, then we'll say that the system is in a steady state and is a stable system, so that's perfectly fine, right? Then we can calculate our LQ. So LQ we're going to calculate with a formula as, because we now know the utilization rho. So utilization rho is actually equals to let's look at, I forgot how much we calculated. Yeah, 3/4, right? Yep. So we took 3/4, right? 15/20 square, right? Divided by 1 minus 15/20, and of course that will give us a total value of 2.25, right? Means customer is waiting 2 hours and 25 or 2 days, 2.25 days here. Then WQ will be 45 days, right? Because we know the LQ now, which is 2.5, right? Divide by 1/20, right? And then you will get 45 days. And L will be rho divided by 1 minus rho, okay? And W will be in terms of 60 days. Now that's our queuing analysis with single server. You may also get, okay, so what if we add, or we require 2 servers, we add 2 resources? So very simply, we're going to still have the same lambda and same average cycle time, but our other calculation will change. So our utilization calculation will be our mu, or average time, will be multiplied by the number of servers, right? And now our rho will be 3/8 or 3/8, right? And then still we'll say that it's still in a steady state, right? Because still is less than 1. And then we can apply our LQ. So in our folder where we, with the week we use queuing analysis, I also left a document for you where the same calculation is explained step by step, right, in a more easy to understand and a decimal form, right? So let me call that file for you. There you go. Still opening. Okay, still opening. What's wrong with this file? All right. Okay. So I strongly advise you to have a look at this example here, okay? Because that's a very easy to understand example. Is going to be extremely useful for your final examination, all right? So slide 42 in our lecture, right? We are given the example of a pharmacy, right? And then we're going to apply this to calculate our queues. So there are 2 methods I explained in this Word document. Method 1, which was used in our slide 42, and of course another method. So both methods will give us the same answers in terms of calculation of our lambda and our average time per customers, right? Yep. And then how we calculate our total time in system, right, using 2 methods, right? So that's of course identical. and then our total time our total time in the system and waiting time in a system, right? And then our total time in a queue and the waiting time in a queue, right? And finally, if we are applying our multi-server MM2, right, then how we actually use the multi-server model. So for example, here all the formulas in the sheets are very useful. I strongly recommend you to go through, practice, right, the formula. Okay, so a few questions or few clarifications I just like to bring it here. So this is our formula, and that looks quite threatening, the LQ formula, but it's quite simple if you break it into its steps. So we know the number of servers, so servers could be 1, 2, or 3. So here the servers are 2, so we're going to replace first 2. We know the utilization is 0.3, which we have calculated before, right? So where did I do that? Is here, right? 0.3. Okay, because we are multiplying 0.67 1667 in by the 2 servers we have. So we just plug in the value into the formula. 2 factorials. Again, your formula should be, your calculator should have factorial. Let's see whether the inbuilt guy has calculated. Yes. So when I calculate my factorial, so you click on 2 and then click on this n exclamation mark and then say okay. So 2 factorial will of course will be 2. Let's test it out. What about 3 factorial? So 3 factorial is 6. It's correct. So 3 times 2 is 6 times 1 is 6. Right? Then 1 minus rho, which is 1 minus 3. So we solve the first component in here, right? We didn't touch the second part at all. And once we are done, now we are okay with that, right? So okay with that, then we apply the second function. So second function is rho divided by 1 minus rho. So 0.3 divided by 1 minus 0.3. We'll address that part here, right? So now the two things are sorted, easy to understand, all right? Then we start applying our bigger issue here. Okay, so what you have to do here is, my n is 2, so n start with 0, right, and 1. So there are 2 things, right? So if it is n is 3, it could be 0, 1, and 2. N factorials, right, because we have 2, so we'll have the 0 factorial and 1 factorial. Okay, remember 2 minus 1, that's our formula. C summation is C, so C minus 1, 2 minus 1 is 1, right? And that's what this particular component is about, right? This component. So yeah, so 0 factorial is going to be 1 and 1 factorial is of course 1. So we solve this particular component and then we start addressing this guy, right? Just like we did the first part of the problem. It is almost same as the second part, right? If you look at, it's almost same as the second part. Okay, and then of course you will have to worry about the -1 exponent power here for this component, right? And when you solve this, right, add them all, take the power function, right, and then you got the LQ as 0.006. I mean, I'm not sure whether I need to go through and showing you steps. Steps are already there, right? You just need practice. And the rest of the stuff is pretty straightforward, which is just plugging in the value, right? And the interpretation. Okay, so these all areas are important, all areas you need to practice, right? And plus of course some of the other are areas. I mean, these are the area which I feel that you should be focusing more on. Everything is of course important, and you need to bring knowledge from the whole unit to answer your questions. Right, so good luck for your exam. As I said before, practice all the tutorial exercises, practice all the handouts and additional exercises. Please don't forget to attend this week's tutorials, because your tutors are going to also explain some of the techniques and recap some of the topics that we have discussed today. So make sure, if you have any questions or if you have anything which is not clear, discuss with your tutors, and prepare for the final examination, and I'll wish you all the best. I believe also you must have received an email from QUT about a survey. So if you have a chance, if you have some time, please do provide your feedback, because your feedback is very important. We work really hard in these current circumstances to develop our course material, to develop our exercises, and to provide additional support to you. So your feedback is really what we need in order to improve our future deliveries of the unit. Once again, good luck for your examination. All the best, and I look forward to see you possibly in our future deliveries of other units. Take care, and bye-bye.